Hello and welcome to Focus Hour Calculus. Today we'll be discussing all derivative rules. Now, if you want to take a look at exactly what derivatives are, make sure to tune into our other video to which we discuss exactly the concept of derivatives and derivatives in the reference to tangent lines and many other topics. But today we'll be just simply discussing the derivative rules and the computation of derivatives. So be sure to tune into both videos if you want a holistic perspective. So, let's get straight into it. The first derivative rule to which you need to know, and also the most simple, is called the constant rule. And the constant rule very simply says that if you're trying to derive a constant c, for example, it just represents all values or all numbers. That would be equal to 0 every single time. And that's it. That's the constant rule. Essentially, it's, for example, a sample question would be find the derivative of negative 279.5. The answer would just be equal to 0. Regardless if it's negative, if it's a decimal or a fraction, or however big, however small, it's always going to be equal to 0. And that's our first rule. Now let's move on to our second rule. The second rule is called the constant multiple rule. And essentially says that if you're trying to derive a function that is multiplied by a constant, so the derivative of c times f of x, and the c is any number, once again, in this case, the answer is equal to c multiplied by the derivative of f of x. In the most simplest term, this simply means that when you're trying to solve this equation, you can simply pull c outside and it would be the exact same equation. So as you can see, the c is outside right now because it came out. It used to be here. And it's the exact same equation. So after that, let's take a look at our third rule. And third rule is called the power rule. Exactly as it says, the power of a function, or for in our case, a variable, is equal to some specific entity. So the derivative of x to the nth power is equal to n times x to the n minus 1. Now let's stop here and do a sample problem. Since we've been through 3 values, or 3 specific questions and 3 rules, let's take a look at exactly how we understand them. So in this case, the question would be the derivative of 5 times x to the 7th power. What is that? You can take a moment to pause and answer. In this case, the answer would simply be 5, since we can simply put it outside. That's the constant multiple rule. 5 times, in this case, as you can see here, n is outside, and n is also the exponent. In our case, the value of the exponent is 7, so multiplied by 7 times x, since it's still there, then multiplied by n minus 1. We're going to understand that n is 7, so it'd simply be 7 minus 1. Oops, 7 minus 1. That'd be equal to 35 times x to the 6th power. And that's your answer. Well, let's move on to the other rules then. Next rule is called sum rule. Sum rule, it simply says that the derivative of a function f of x plus a function g of x, all within the derivative, by the way, is simply equal to the derivative of f of x. And notice that I'm using the prime value here to express derivative. It doesn't have to be d over d of x. It seems a little more complicated and takes a little more time, so I'm just using prime here, plus g prime x. That makes a lot of sense, actually. It's pretty intuitive, seeing as you simply derive each value by itself rather than doing it one by one. So a sample question here would simply be, what is the derivative of 5x squared minus 2x plus 1? Oh, it's 2 plus this time. 5x squared plus 2x plus 1. What do you guys think is the answer? Okay, let's try it ourselves then. In this case, we first have to see that by the sum rule, we can simply separate all these three terms into individual areas to solve. So let's do them one by one then. First, find the derivative of 5x squared. What's that? So we can go back to the power rule to understand. Well, first let's go back to the constant multiple rule to get rid of the 5. 5 is simply multiplied by the derivative of x squared. And what is the derivative of x squared? Well, n in this case is equal to 2. So multiplied by 2 and add x. And the exponent of x is equal to n minus 1. In this case, n minus 1 is equal to 1. So we simply leave it as b. What's next? Next is 2x. So we first separate it. 2 can just come out. And after that, there is x. So this is synonymous to x to the first power. And x to the first power is simply equal to 1, that's n, multiplied by x to the 0 power. And since x to the 0 power is just 1, we can cross it out, so it can be the 1. And last but not least, it's the value 1. And go back to the first rule we discussed, the constant rule says that any constant being derived is simply equal to 0. So plus 0, which we can once again cross out. So in this case, the answer will be equal to 10x plus 2. And that's the solution. Okay, let's take a look at the next rule then. The next rule, let me just go down, is the difference rule. And as you've probably guessed, it's simply the difference between the functions f of x and g of x. So before, in the sum rule, we understand that f of x minus g of x is just equal to f prime of x minus g prime of x. And in this case, it's the exact same thing, just the opposite way around. So in this case, f prime of x minus g prime of x is equal to the derivative of the collective f of x minus g of x. And that's pretty much it. So let's take a look at the next rule then. What about the product rule? Now, in the case of the product rule, as you've probably noticed with the names, that's simply the derivative of the product of the two functions f of x and g of x. And unlike those two previously, the sum rule and the difference rule, this is going to be a little more complicated. And it's a formula that you'll have to memorize. Because the answer is equal to f prime of x multiplied by g of x, no derivative, not being derived, which is crucial here. It's not derived, plus f of x, which is also not derived. Once again, crucial notice, multiplied by g prime of x, which is derived. So these two are derived, and the other two aren't. And that's the product rule. If you want to multiply two functions within a derivative, the answer is equal to the derivative of one of the functions multiplied by the normal other function. And after that, the normal first function is multiplied by the derivative of the second function. And that's the power rule, product rule. Now, let's get into the sample questions later after we discuss the quotient rule, and then we can consider them all together and do a few questions right after. So in this case, the question becomes the quotient rule. Quotient rule, which, as you've probably guessed, is just the derivative of f of x over g of x. Now this is going to be a long one, and just like the product rule, it's not going to be as straightforward as the sum and difference rule. And as you can see, I'm drawing a big line because there is a large numerator and a pretty large denominator. So it starts off with f prime of x multiplied by g of x, not being derived, crucial to notice, subtracted by f of x, not derived, and g prime of x. That entire thing over g of x, once again not derived, squared. And that's the quotient rule. And you might be thinking and looking at this like, what is this? This is so huge. How am I going to memorize this so soon for the test? Or any test or any learning curve that you might be facing? Well, in that case, I have a very good piece of news for you because I have a rhyme that might just help you get through the test. Now, stick with me here. Since this is the numerator and this is the numerator is higher than the denominator, right? So let's call this high. And since it's lower, the denominator should be called low. In this case, and you can sing it with me through the screen, it's going to be high here as f of x and low here as g of x. On the other hand, if we're trying to find the derivative of that value, simply add a d before the said value, like d high or d low. Okay, so here's the rhyme. Low d high minus high d low over low squared. Once again, let's sing it again, just so you have a brighter idea of it. Low d high minus high d low over low squared. That's how I used to memorize it because I'm not a good person at memorizing, but you can choose your own method. It's pretty embarrassing to say it out loud, but that's my strategy for memorizing just because it rhymes with a familiar restaurant, which I like, but also because I find it very useful. So if you find it useful yourself, feel free to try it. So once again, we can go through it again this time. It's going to be low d high over high d low over low squared. So sorry, minus here. Let's say that again. Low d high minus high d low over low squared. Okay, so you probably had enough. So let's do a few sample problems just to try it out before looking at our final and most complicated question yet. In this case, the practice problem becomes, what is the derivative of x cubed plus 7x squared minus x over x squared plus 1? You can pause the video and try it out for yourself, and we'll do it together. So in this case, you might be thinking, okay, so I have a few numbers, but first of all, I have the top and the bottom, which are all variables and which can all be using power rule and sum and difference rule to solve. And you'd be right, except for the fact that we have to take a look at the biggest function or the biggest variable that is seen right here. And that's the entire thing being divided. The division is the most important area to which we have to see. And therefore, when you see any division or multiplication take over, you have to start with the quotient rule. So in this case, we're doing the quotient rule first. So in this case, once again, let's go back to the rhyme. Let me draw a line. Low, x squared plus 1, d high, so the derivative of the numerator, in this case would be, first deriving this, power rule, 3x squared. And then since we just added the second one, this would just be equal to 14x. And subtract the difference rule here to x. X would just be equal to 1. And that is the first tiny step. Okay, what about the next one? Low d high minus high d low. So high is just the numerator repeated. D low, let me just open this a bit. The derivative of the denominator, once again, we just have to get rid of the 1 here because it's simply a constant. And take a look at what x squared derived is, and that simply be 2x. And that entire thing over low squared. So x squared plus 1 squared. And you can solve it by yourself, but that looks pretty complicated and I don't want to solve it over that period of time, so I just won't. but you're welcome to try, and good luck with that. Okay, so let's go to the last rule of this entire lesson. That's going to be the chain rule. The chain rule is the most important rule by far, and it will help you solve literally all the problems that you'll be facing in a more complicated textbook. In this case, you're asked for the derivative of f of x of g of x. So g of x being placed into f of x. In that case, the answer would be equal to f prime g of x multiplied by g prime x. And this might seem pretty complicated, but you'll understand once we do a few practice problems. So let's do a practice problem. In this case, the question becomes, what is the value of x, or the derivative, apologies for that, the derivative of x divided by 2, and that entire thing squared. It seems a little messy, so let me just pull this back. What is the answer to this? You can pause the video and try given this specific formula. Now, let's first make sure to see which one or which function comes first. So you see that x over 2 is squared, but x is also divided by 2. But understand that when you're solving an equation, assuming x to be a number, you always square first. So the squared comes in first. Let's assume that that certain function is equal to the squared. Another function is equal to dividing by 2. In that case, the squaring function will always come in first. And for that reason, let's prioritize the squaring function and assume it to be f of x. So here, let's do this again. Assuming that x over 2 is a singular entity, how do we solve x squared or derive x squared by power rule? Simple. It's just 2x. But right here, this is just not just x anymore. This is this value because that's what we're substituting to be x. In this case, we just need to substitute it back in to be x over 2. And that multiplied, since that's the formula, multiplied by the derivative of 1/2 x. And that would just equal to 1/2. Okay, so let's simplify this. 2 and 1/2 cancels out, so the answer is just x over 2. And that's your answer. Okay, you might still be a little confused, and that's completely fine. Let's do an entire problem now then. So let's try a problem right here. In this case, we're using all of our rules. So the question becomes, y is equal to x cubed plus 7x squared minus x, and that entire thing multiplied by x squared minus 1. And then, collectively, it's going to be squared. You can pause the video and try yourself, and after that, we can try it together. Okay, so first and foremost, let's take a look at exactly what operations are coming down right now. So first, we have the squared, and then we have the multiplication. So the multiplication is solved by the multiplication rule called product rule. But then the outside equation, or the outside function, is a chain rule instance. And since we always square before we multiply, we have to solve the chain rule first. So let's assume that this entire thing is equal to a value, u. In this case, this function is just equal to u squared. So how do we derive u squared? The derivative of u squared is simply 2u. And that would be 2 x cubed plus 7x squared minus x multiplied by x squared minus 1. Now let's put it another way then. That would simply be equal to the derivative of this huge function. And then all I have to do is use the constant multiplication rule to place, oops, I zoomed out by accident, to place the 2 outside. And then after that, we can do this again by using the product rule. The product rule on these two functions, I forgot to end it, would be equal to f of x multiplied by the derivative of g of x, assuming that this is f of x and this is g of x. Let's do that same thing. So f of x, x cubed plus 7x squared minus x, multiplied by the derivative of the second function, that will be equal to 2x. And that entire thing we just have to add to the derivative of the first function now. That would be 3x squared plus 14x minus 1. And that entire thing we then just have to multiply by g of x, which is x squared minus 1. In that case, we just have to multiply this entire thing by 2. And since I don't want to simplify it, we'll be going over how to simplify this huge entire thing in another video. That's our answer. All right. So I hope you understood and I hope you enjoyed it. Thank you for tuning in.